So for this section, for this problem, they ask us to find the z center of mass, it's called. Okay, so this is one of those things that I was talking about. You can just find the formula in your book, basically, on the certain page at the end of this section. And so this is going to equal the m, well, hold on, that is a really bad m. Okay, so this is going to equal m of xy over m. And these, respectively, are triple integral over w of z rho of xyz dv over the same thing except for without the z, basically. So then we have the following. Okay, so as I said before, these are kind of not repetitive, but it's just like you're doing the same thing over and over again, but just with a physics twist, which is good because then you get more practice with calculating integrals. So here, we're also given that rho of xyz equals y, okay? And let's see what else. And then we have that rho goes from 0 to 1, and phi goes from 0 to pi over 2, and theta goes from 0 to pi over 2 as well. Okay, so I just figured it out. So pretend you didn't see any of this. Well, except for, okay, stop. So this is your given. Sorry about that. I skipped ahead of myself. I was looking at my work. So what they do give you is everything on top of the line, and that we're integrating over the first octant sphere. The first octant of what they call the unit sphere. So whenever you hear the word unit, you should think of 1. Like the unit circle, you know how it's just a radius of 1. So this crosses the x, y, and z axis all at 1. Okay. So this is how now we're going to determine the bounds for rho, phi, and theta. So we'll start with rho. So this is our spherical radius. So the radius goes from 0, because it has to be positive, up to 1, right, in all directions. So 0 to 1, that's how we got that. And then we'll look at phi next. So phi starts at the top here, and it goes down to, so it goes from 0, phi equals 0, all the way down to here, which is where phi equals pi over 2. See how if we go any lower, it's going out of the region? Yeah. So anyway, so that goes from 0 to pi over 2. And then now let's look at theta. So theta starts on the x-axis, so theta equals 0 here, and it sweeps across on the xy plane until it gets to this point, which is where theta is also equal to pi over 2. So theta goes from, I'll write over here, theta goes from 0 to pi over 2 as well. So that is how we got our bounds, not magically like I just wrote them. Okay, so now at this point we're ready to, well, we're almost ready to set up the integral. We do need to know, let's keep in mind that x equals, and like I said, it's always useful to just continue writing these even if you may not need them for a problem, but it's good to know that x translates into this in spherical coordinates. Y is almost the same thing except for the theta thing, the theta term changes into a sine instead of a cosine, right? Everything else is the same. And then z equals rho cosine phi. Okay? So that's good to know. And now we can set up our integral. And I shall do so at the bottom here. So we'll start with d theta on the outside. So 0 to pi over 2. And then I'll make d theta be all the way over here because you never know how much room you might need. And then we'll do the phi bounds. So 0 to pi over 2 as well. It just happens to be the same. So d phi, okay? And then we have our rho. So 0 to 1. And then d rho. And you can't forget the Jacobian, remember? Okay, so now we just fill in the middle here with whatever we need. And in this case, it will be y, right? So, but we're actually, okay, sorry. To clarify, I'm doing this top integral first, okay? So this top integral says that I have to do exactly what I'm doing so far, except for along with the function that we're given, this thing here, I have to include a z, a random, I don't know why the z is there, because I guess that's just included in the formula. So anyways, we're going to include some z. So I'm going to include this part here. That's like an extra term in the front there. That's just because the formula tells us to do that. So this is like, this represents z. And then our function is y. Okay? So now we just plug in this for y, for the y spot. So y is represented by this, sine theta, sine phi. Okay? So yes, that is quite a handful there, but we're just going to combine all the terms and continue solving like normal. So I'll combine them in the next slide. Okay, so what we have is from 0 to pi over 2, and then 0 to pi over 2, and then from 0 to 1. And if I combine all the rows, we get rho to the 4th. If I combine, well, there is only one theta thing, so sine theta. And then we have a cosine phi sine squared phi. And then we have just our differentials here, d phi, d theta. Okay, so at this point, again, this is iterated, so we can break it up into the 3 different sets of parentheses. So we'll start with the theta ones. So we have the pretty simple theta ones, right? Something like that. And then I'll do the, I guess we could do phi. So from 0 to pi over 2, and the phi stuff, so that's cosine phi sine squared phi d phi. And lastly, we have the rho. So from 0 to 1, rho to the 4th. Oh, premature parentheses there. D rho, and then close parentheses. Okay, so let's start evaluating. We have a negative cosine theta, as theta goes from 0 to pi over 2 here. And then here, I'm going to, I'll make it over here. I'll make u, we're going to do u substitution here. So u equals sine theta. So du is then going to be cosine, sine phi. And then this is cosine phi d phi. I told you I always want to call everything theta. But anyways, d theta is then du over a cosine phi. Alright, so we're going to implement this here. So we'll have we can't really do anything with the cosine theta, cosine phi, but we can replace sine phi with u. So we have u squared. And then d phi is now du over cosine phi, which is good because then those cancel pretty conveniently. And then we'll just continue solving on the right here. So we have rho to the 5th, as rho goes from 0 to 1. And then we'll plug this in. So we have negative cosine pi over 2 going on over here, plus a cosine 0. And then in the middle here we have integral of u squared du. We'll just leave that there for now. And then this is a 1 over 5, 1 to the 5th minus 0. Okay? So then this in front, that's 0. This is a 1, right? Cosine is 1 at 0. So then we have a 1 times 1/5. So I'll put the 1/5 in front. And then we have 1/3 u to the u cubed. And then I'll replace that. So I'll combine the coefficients and replace u with sine. So then we have sine to the 3rd phi, as phi goes from 0 to pi over 2. And now we'll simply solve for the rest. So then we get sine to the 3rd pi over 2 minus sine to the 3rd 0. And sine at 0 is 0. And sine at pi over 2 is 1, right? So that'll be a positive 1. And so our final answer is just going to be 1 over 15. Okay? All right. But that actually is not our final answer. Sorry about that. I made it. See, I was trying to see if you're awake there. So this is our top integral, right? This was the one where you had to add in the extra z for some reason, just because it's according to the formula and etc. etc. So that was the top integral. So this is like part 1, yay! So that this was actually more complicated than the next one's going to be, so that's good. We got the hard part out of the way. So just keep a little note of 1 over 15 in the corner somewhere on your paper, and we'll solve for the second integral, okay? So now this second integral looks like this. We're going to do the exactly same thing, except for now we don't have that random like z in front, so we'll just solve it like normal. So what this is going to be is the same thing, like I said, 0 to pi over 2, 0 to pi over 2. The region is still the same as well. We just don't have the annoying like z in front. And then 0 to 1, okay? And then we'll solve, this is our y, right? When we plug in y, this is what we had. So that represents y, which is this part, okay? And then we have our Jacobian, which is the change in volume when we do our change in variables. So d rho, d phi, d theta, and we'll continue on here. I'll break up, I'll put all the thetas together. So 0 to pi over 2, and then we have sine theta again, and d theta, okay? And now I'll put the phi's together, 0 to pi over 2, and we have sine squared phi, d phi. And then lastly we have the rows, so that'll be rho to the third this time, d phi, or d rho, sorry, getting everything confused. Okay, so that's how we set it up, and then we'll continue to solve. So we have our negative cosine theta, and that goes from 0 to pi over 2, okay? And that's there, and then we have, okay, so this sine squared phi, remember before we did this, and that was actually equal to 1/2 1 minus cosine 2 phi, right, because of the double angle formula. So anyways, I'm just going to plug that in here. I'll bring the 1/2 out in front and have our 0 to pi over 2, then 1 minus cosine 2 phi sitting there, d phi. And then at the end here we have a 1 over 4 rho to the fourth, as rho goes from 0 to 1. Okay, we're almost there. So what this turns out to be, as we calculated like right in the problem before, this is going to be just a positive 1, okay? And then I'll just bring all the coefficients to the front. So then we have a 1/2 here, contribute from the middle contribution, and then the last thing here threw in a 1/4, okay? So we took care of those. And now we just are left with the following. The integral, and I'll break this up. So we have 0 to pi over 2 of 1 d phi, and I'm just breaking it up with the minus sign here into 2 separate integrals so we can deal with them easily. Okay, so this is what we're left with, and so in front we have a 1 over 8, positive 1 over 8, right? And then this is just pi, okay, wait, that's supposed to be parentheses, and then when you plug that in, that's just pi over 2 minus 0, so just pi over 2, and then minus this last integral that we have to deal with here, and that's going to be, we'll do u substitution. So this is our u equals 2 phi, du equals 2 d phi. So d phi by itself is just du over 2, so we'll just sub that in here. So we have cosine u, and then d phi is du over 2, okay? So that will be a 1 over 8 times pi over 2 minus, and I'll bring this 1/2 right there, 1/2 sine u, okay? And then I'll sub back in u, or I will sub in 2 phi for u in the next slide. So then we get 1 over 8 pi over 2 minus 1/2 sine 2 phi, as phi goes from 0 to pi over 2. And now we'll just plug that in, and we get 1 over 8 pi over 2 minus 1/2 sine 2 times pi over 2. Okay, another parenthesis, minus sine 0. Okay, how many parentheses do I have going on here? I think I need one more. Yeah, okay. And then this is sine pi minus sine 0, and at both of those points, sine equals 0 itself. So then we get, our final answer is pi over 16 for this part. So this was the bottom part, right? This was the integral over w of the following. I'll just write that pretty quickly. And remember, the note from the first part was 1 over 15, and this was the top one. So this was the z one, x, y, z, dv. Okay, so our final answer, which is z, I believe that's like center of mass or something like that. This is going to be this over this. So this is the top, and this is the bottom. So that just means 1 over 15 divided by pi over 16. Okay, so that's just going to be 16 over 15 pi, which is about equal to 0.34. And that is our final answer. No jokes. Because if I was joking, that this would be a really long problem. But anyways, so that completes that problem, and I hope that helped. And I'll talk to you in the next video if you watch.
I got friends in New York City, 'cause everyone I know left town.